Hello everybody, how are you today? How many of you, is this your first time attending Refactr or basically the Re-Rise conference? How many is the first time ever attending one of our conferences? That's awesome. I'm glad to see y'all all here. I appreciate you coming. It's the third year that we've done this conference. We had to rename it. It was called Re-Rise the first 2 years, and we renamed it this year's to Refactr. And we hope to make it bigger and better each and every year. So hopefully we'll see all of you back next year, and bring your coworkers and your friends also with you next year. I'm going to actually go ahead and start just a few minutes early. The reason why we have 45 minutes for the track, when I do my presentation, it normally runs about 50 minutes. So I'm going to just talk at like 1.2 speed for 45 minutes. Hopefully I'll leave a little bit of room for questions at the very end. And also at the very end, I'm going to be doing a live demo, so I'm going to hopefully do everything correctly as long as I don't touch the cables, because when we moved my computer earlier, the connections display stopped working. So hopefully it will work on here. So thank you for coming. My name is Jennifer Bland. I'm going to give you some information about myself. My website, if you were interested in following me, is appropriately named jenniferbland.com. I also have training courses that I create on a website called codeprep.io. So feel free to check it out. I'm a senior software engineer at Stanley Black & Decker. You've probably heard of Stanley Black & Decker. We make the hammers, we make the tape measure. So as part of their IT department, my job is to make a better hammer. No, just kidding. We make applications for Stanley's factories worldwide. And that's what our department is responsible for doing. I'm also a Google Developers expert. Every time I start one of my presentations, I also do this little short quiz that's called 3 Truths and 1 Lie. There are 4 facts that are on the screen here. 3 of these facts are true about myself. 1 is not true. At the very end of my presentation, I will come back to this slide and let you guess which one is not true, but you have to stay until the end of my presentation to find the answer. So the 4 things that I have up here, number 1 is I've climbed the highest mountain on 4 of the 7 continents. Number 2, I graduated university with a 4.0 GPA. Number 3, I asked Prince Charles for his autograph at a Georgia football game. And the last one, number 4, is I own more toy soldiers than Sir Winston Churchill. So think about that, marinate on it, and at the very end, I'll give you a chance to think about it. But my talk today is about the JavaScript stack trace. And in order to talk about the JavaScript stack trace, I need to give you some background terminology. That is, as long as you understand this in the beginning, as I go through the latter part of my presentation, things will make a lot more sense as to what I'm talking about. So when I talk about terminology, let's start with the very basics. What is JavaScript? And JavaScript, it's a single-threaded, single-concurrent programming language. And basically what that means is that it can only handle one task at a time or one piece of code at a time. This image that we have right here is a representation of the JavaScript concurrency model, which is made up of the call stack, the heap, and the queue. So let me go through and explain those 3 items to you. So the first thing that we have here is called the call stack. And what the call stack does, it records all the functions that go on within your code itself and where you are within the code. So the way that it works is it basically creates a stack. And it's the first thing that's done is put at the bottom of the stack. Next thing is put on top of it, and the next thing is put on top of it. And as things are executed from the top of the stack first, not the bottom, but the top of the stack here. So now I have a little bit of an animated GIF here that I'll play for you in just a second. But what we've got here on the screen is you have a function called foo, you have a function called bar, and at the very bottom, I'm doing a console.log where I'm executing the function bar. And when you look at it, the way that this works, and I'll start the animation, is it over here in the stack, as it calls bar, it puts that onto the stack. It puts, that calls foo, which puts it on the stack. When foo finishes running, it's popped off the stack. It's returned to its calling point, which is the function foo. That executes. It's pulled off of the stack. And then you basically return to the console.log where you started. So that gives you an idea of how the stack trace, come on in, how the stack trace works. So the next thing that we have when we look at the JavaScript concurrency model in terms of terminology that you need to know is what's called the heap. And the heap is very simply the memory that your program has in order to execute your code. Every time you create a new variable, it's put into the heap. Every time you run a function, it's put into the heap. Sometimes you've seen scenarios in which your application crashes because it ran out of memory. And it's because you ran out of space that's been allocated to your program in the heap itself. And a lot of times that happens is when you have a recursive program that's in an endless loop, and so it's just constantly creating things, and it's just putting things out there into the heap, and eventually that cup runneth over, and when it does, your program crashes and burns, and then you end up getting an error message. The heap is basically finite in size, so you're given a set amount of space for your application. You cannot go over the amount of space that you've been given. And then the next thing that you need to understand is the queue, and what JavaScript does in doing its execution, because it's single-threaded, it basically has a queue, and all of the messages are put into the queue, and things are associated, all these messages that are put into the queue, especially if they're asynchronous messages, will have an associated callback, and that callback will be executed once that code actually finishes running. And there's a limit in terms of how much you can put into a stack at any one time, so you have to take care of that. And sometimes you will see error messages that will occur as a result of you overflowing the stack itself. So now that I've given you some basic background terminology and so forth, the question is, what is a stack trace? And basically what it is, it's one of the most fundamental tools that you as a programmer will use when going through and debugging your code. Because it reliably will tell you where an error occurred in your code itself. And what it will do is it will tell you very detailed information. It will tell you what function it was currently executed when an error occurred. It will tell you the order that functions were called in your code, so you can basically see where the progress of your code logic was happening, and you can see where it might have possibly gone wrong. It will tell you what file was in and the line number it was on when your program crashed, so you can actually start there and try to determine what's going on. It will tell you if there was a function that it was working on, what arguments were being passed into that function. So you can see what type of data you were getting, because sometimes that can be a cause of all that problems. So the first question you might ask is, where does all that information that you're getting from the stack trace, come on? So let me give you an example here of a demo of a traditional stack trace, where something goes wrong. On here, I have three functions. I have a foo function, a bar function, and a baz function. And at the very bottom, I'm going to execute as function. So if you look over on the far right side of the screen, this is the stack trace, and it will show you what's going on. And remember, I told you things are put in the stack first. The first executed is on the bottom, next thing is on top, next thing goes on top of that. So when you want to look at the order is read from the bottom to the top. So when you look at this, the very bottom thing that you have is what's called anonymous function. Well, you're like, I don't have an anonymous function. And the reason that you see a thing like anonymous function is this baz function is executed on what's called the global scope. A lot of people refer to it as the window. So the window by itself, that global scope, is an anonymous function. So that's where you're going to start, is with the anonymous function. And then it goes into the BAS function. And if you look at BAS, the only one line in BAS is it calls the bar function. So the next thing in the loop in the stack trace is bar. Bar calls foo, and there, so if you have foo, then that throws an error message, and it has the information that's on there. So the stack trace tells you the order of things that were being executed in your code right before something went wrong. So you can see all of that information there in that stack trace. Now, most of the people, when they try to debug their code, the first thing they do is they start sprinkling console.logs, and they'll print things out so that as their code's executing, they'll start to see what's going on. How many people use console.logs when you're programming? This is perfect. I will give you a lot of other options that are available to you, and some of them you might find might be a better solution than just throwing copious amounts of console.logs within your code. The console method actually has multiple ways of doing debugging. Here I've got 5 different ones that you can use instead of just using the console.log. So you can do a console.debug, console.info, console.warn, and a console.error. Now let me give you an example of how this might work. Here I've got a very simple function that gives you an example of what every one of these console.logs look like when you try to run them. And at the very bottom, I actually end up that function so you can see the results of all of them. Now, let me ask you this. How many of you use Chrome as your primary browser when you're doing development? How many of you use Firefox? Okay. The way that it handles this is different between these two browsers. So to show you an example of how it works, I've got a very extremely simple HTML file that basically in the body, it loads that JavaScript file that I showed you on the previous slide in the head, and then it has a message that tells you to go look at the JavaScript terminal to see the results. What you will see in Chrome is that you will see this is your output based on all of those different console functions, methods that you're using, and so forth. What it does is it will color code these informations. So console.warn will have like a yellow background. It will have different color text. The console.error will have a red background. It will have a red text. 3 of the different calls will have an icon next to it, so you can see that. Sometimes if you were using a console.error and you look at your dev tools, you may not see that. And the reason why is that you need to set a setting. By default in Chrome, you're not able to see them. So let me show you what the exact same thing looks like in Firefox. Firefox will give you the same information, but they do things a little bit different. And what they do different is all of them are printed out in the exact same color. What they do to distinguish between the different console calls is that they use different icons on the side of the screen so that you can tell the difference between them. Now, I'm going to break out of here, come over here to my code. Can everybody see that? Move this over. Has anybody ever tried to program over your shoulder and backwards? It's like a challenge. What I have is I have my simple HTML file that I'll be using for my demo, and I have this logging.js file. And when you look at it, it's the exact same thing that what we were looking at previously. Now, if I come over here and I hit refresh, in Chrome, you see only 4 of them. And what I mentioned earlier is you have this custom levels. By default, errors is not selected in Chrome. So once you put it in, you now see the console.error. So if you start to use all the different methods and you don't see them all, just make sure you change that setting in your console.log. Now, if we come back over here, I'm going to start playing again. All right. Now, the next thing that I want to show you is, besides the 5 that we just talked about, there is another one that I think that once you see the efficiency that this provides you, this might be something that you start using besides using a console.log when you're going through and troubleshooting your code. And it's console.table. And it does exactly what you think it does by its name. It will take whatever parameter that you pass into it and display it as a table in your console. And it makes things a lot easier to see and do things back and forth. So I'm going to break out of here, come back over to my code, and down here I have this array called animals. Hopefully I've got my font big enough so that everybody can see it. And what it is, it's an array of objects and so forth. Now, what most people do is that they console.log here. I'm going to come up here and comment this out so we don't see the console.logs. And change this, come back over to my browser, refresh. This is what most people do, is they console.log out the object that they want to see. And what you end up having to do is you have to click on this to drill down. You see the array, you see the items that are in there, 3 items, and you have to drill down on it to be able to see the information that's on there. How many people constantly do something like this when they're trying to debug your code? Let me make your life a lot easier. So if we come back over here, so I'm going to keep that previous console.log out. Let me save this, come back over to my browser, refresh. Now, which one is a lot easier for you to use when you're debugging your code? Now, since I'm doing a console.table of an array, what it'll do is it will give me the index, because there were 3 items in my array. Arrays in JavaScript are 0 index. So you see 0, 1, 2, 3. You see, all the things that were in the object itself, everything that's on here. Now, the other thing that it gives you automatically is you can click on any one of these things and it will automatically sort the table in ascending order. You can click on it again and it will sort it in descending order. You can click on any one of these columns to get that information for you. It makes things a lot easier. Now, one of the other things that you can do is, all right, let me comment this out. Comment this one out, comment this one out. Now down here, instead of an array of objects, I've got an object that consists of objects within the object itself. So we'll go through and do the exact same thing as we were doing before. I'll do my console.log, come over here, refresh, and we're back to the same thing that we're used to doing when we do our console.log. When we expand this out, okay, we've got the object, we have to drill down on it again, and now we're able to see it. If I want to see what was on all of them, I kind of have to expand all of them to be able to see that. If, on the other hand, if I come over here and I do a console.table and come back, refresh, now what I have is the old way, the better way when you do it through the console.table. Previously, when we were doing an array, we had the indexes. Instead, now since we have an object of objects, here are the keys that are found on the original object, and then here are the values. And just like you could with the array, you can click on it to sort it, click on it again, and sort it in descending order. This makes things a lot easier to do. Now, the first question a lot of people ask me is, that's great, but when I create objects at work with my programming skills, my objects have a lot of keys on them, and it has a lot of data on them, or my arrays have more than just 3 objects in it. That's great. Let me show you how to handle a scenario like that. So let me come back over here. Let me comment this out, comment this out. One of the things that you can do is, when you do the console.table, let's say I just want to see the name of all the turtles. I don't want to see anything else. I just want to see that. So let me save this, come back over here, and look. Now I'm able to see this one thing that I wanted to see out of the object. It's the same thing if I was doing it on the array. But let's say I want to see name and something else and not be limited to just one thing. Well, you can definitely do that. If you want to do one, you just put a string in as a second parameter that you're going to pass into console.table. If you need to do more than one, let me comment this first one out. And what you'll end up doing, if you need to do more than one that you want to display, you pass an array of strings, and the strings are the values that you actually want to be displayed. If I come back over here and click on it, I'm able to see those two things that are on there. So doing a console.table is a great way to go through and make things a lot easier for you when you're going through and debugging your code. Now, let me go through and go back to my slides. So the next thing that we want to talk about is actually creating a console.trace. And the console.trace is the stack trace that I showed you earlier. Remember that the trace always goes from the bottom to the top. It starts executing at the bottom. What's being executed next is whatever's on the top of the stack. So last in, first out, LIFO method, that's how the stack traces actually work. So here what I've got is an example of three functions I have, and I'm going to start from the bottom to the top to explain how this works. I have a main function, and in it, it's going to call the add function, and then it's going to call the calc function. If you look at the add function at the very top, it has a console.trace on there. So we'll see it. Every time it hits the add function, it's going to console.log out a trace for us. And then if you look at the second line in main, it's going to call calc. And when it calls calc, it's going to call add twice, because it's going to be adding on the left of the plus and the right of the plus. So in order to see what that looks like, if you actually look at your browser and you look at the output here, you will see things and you'll see it as it went through. So the first time it hits main, it hits add. Then the second time through, it goes from main to calc to add. Then the last one, it goes main, calc to add. Because remember, calc calls add twice. That's why you end up with these two stack traces at the bottom. And it always starts with anonymous, because remember, everything starts at the global scope or the window, so therefore it tells you. Now, one of the things that you need to be aware of when you start looking at this trace is it tells me the name of the file that it's in when it was running the code. So it tells me I was in a file called logging_trace.js. How many of you have code at work on applications that you work that have made of multiple files? I mean, many files. I mean, huge. Most big corporations have big applications where things are broken down into multiple files. The stack trace will tell you the name of the file that it was on, and then the thing to the right of it after the colon is the exact line number it was on when that occurred. So you can get an idea of the history of the logic of your application, what was going on right before something happened. So that's why you should be able to use the console.trace. So the reasons so the question is, why should you use console.trace instead of console.log? And the reason why is, how many of you, our company does this, but how many of you have a company that when you take your code and you push it out into production, you are not allowed to have any console messages in production code? How many of you have that rule? Okay, so if you're debugging and you've got files, multiple files that are out there, and you start putting console.logs because it calls this file, and this calls this file, this calls this file, and you put a console.log in all of them, and you get ready to, okay, I fixed the problem, I need to push my code to production, and you forgot a console.log in one of those files. Well, that doesn't go over well, with management, that we make that mistake. Sometimes if you have very good pipelines, it won't allow you to push your code if it's in there, so therefore you get stopped along that lines. if you keep putting copious amounts of console.logs in your file, that could be a slight hiccup that you have when you get ready to move your code into production. If you think that you know where the problem is, you can put a console.trace inside a function, and you can see everything that occurred up to that without having to put console.logs in all the files up to that point, and it gives you that history. So therefore, when you get ready to solve the problem and you get ready to push your code into production, you've got one line of code that you just need to remember to remove so that you can move your code out into production. So, and then like I said earlier, the console.log, console.trace will tell you where the files are, what lines it was on, so you can basically backtrack and go through that and be able to find that history. So the next thing that I want to show you is the ability to do debug. Let's say that you're working on a project and somebody says, I need for you to go fix this bug in this code. And it might be a code set that you've never ever worked on, and you're like, okay, I don't know where anything is, so that's why a lot of people start doing console.logs, just trying to figure out what the logic of the code is, because it's something that's new to you to be able to do. Well, one of the things that you can do is do a debug, and this allows you to find out exactly where something is within the code itself. So let me give you an example of how that works. So let me stop this, come back over to my code. Let me comment out this last line. Where's my cursor? Ah, there it is. Come up to the very top. I have these 5 lines. All right, let me save that. Now, what I have is I'm going to open up one of them. I have 5 files. Pretty much the content of all 5 files are the same. They have 5 functions in them. So where is it? 1 has a file, function 1, which gives you a console.log, function 2, function 3, function 4, function 5. If you looked at where is it 2, it will have function 21, function 22, 23. Where is it 3 would have 31, 32. So everybody gets an idea of what's going on here. So if I come back over to my code, save this, go to my browser, hit refresh. Now, what I can do is if I want to execute that first function, I can put it in here, and basically it does that console.log that says, function 1 and everything else like that. Now, if I want to know where function 33 is, for example, I can put in, if I can spell, debug, and then I can put in, let's say, function 31. All right, put it in. Now, what that is going to do is the equivalent of putting in, where you put in a stop in your code so that as your code's executing, the debugger will stop at that point. This is equivalent of doing something along that line. Now, when I come over and I execute function 31 itself, so let me put it in. When I hit enter to execute it, what's going to happen, because I've already put in that debug point in there, is it's going to stop running the code. It's going to open up the source file that contains the function that I just put the debug line on, and it will put me at the first line of the code of the function itself. So therefore, if I want to debug things, let's say maybe you're debugging something that's in production code, or something along that lines, you can use a debug, so you can put in debug statements automatically, and you've not put anything into your code that you have to remember to remove before your code goes into production. So this allows you to do, console.logs one way, you end up with a lot of them. Putting in a console.trace is a little bit better way, because now you have one line that you have to remove. Now you can actually go out, don't put any lines in your code, and then be able to use the debug itself to be able to find what's going on. So Let me come back over to my slides. Find my... So one of the things is, why do you have errors that occur in your code? That therefore you end up having the need to be able to trace what's going on in your code. And usually these are the most common types of error messages that you will see within your code itself. If you look at the most common reason that code fails, it's usually a problem with the data. There's something going wrong with the data. You might end up doing something like you have an array that has 3 items in it. So you have index 0, 1, and 2. Somewhere in your code, you might try to find index number 7. Well, that doesn't exist. So that's going to generate an error message. So that's a problem with the data where you're trying to get something that doesn't exist. You know, another example is you might have a function that's expecting a string as a parameter, and for some reason something went wrong and null is passed in as a parameter to that function. Well, that will cause, you know, an error message because you're trying to work on something that doesn't exist. Another example of an error where you might have problems with data would be, let's say you're making an AJAX call and you're doing an AJAX call to call your API on the back end to get some data so that you can take that data and display it to the users on the front end. But when you're typing in that URL, you just fat finger things. Like instead of typing in HTTP, you might have typed in HTTP, you know, and something like that, or you just typed in the URL wrong, so that when the code executes and it's trying to go out and fetch that data, well, it's going to fail because it's trying to hit an endpoint that does not exist. So those are the most common reasons of what's going on, you know, why you end up having problems. So a lot of times you go through and you write your code and you're like, well, how do I debug code once it's put into production and your customers are using it? Because you might end up with a customer that's using it with a browser that you didn't test with. They might be using a browser you've never heard of. They may be using your application on a device, like a mobile device that you've never heard of, that has a browser built into this mobile device that you've never heard of, you know, and you don't know why things are going wrong. So there is a way that you can actually, in your production code, be able to catch when things fail for your users. So let me show you how you can go through and do something like that. There is remember the global scope is the window? The window has a built-in method that's called onError, and it provides you a callback function for you to be able to do something whenever an uncalled error occurs in your application. And when you have an uncalled error, that's when your application crashes and burns and you can see what's going on, and you know the user's like, I don't like this application, and they stop using it. You don't want that to happen. So what you can do is in your code, you can put in this window.onError function that will capture any uncalled errors. Inside that callback function, 2 things I recommend that you do. Remember, you can do a console.trace to see what was going on up until the point where something happened. If you have an uncalled error, you're going to end up in that function. So go ahead and run a console.trace because it'll tell you the steps that will lead up to right before you have a problem. Now, once it happens, what I recommend doing is your company can have a server that's open to the public, that in your code, if you get into this function, this callback function for the console.error, you can actually have it take that console.trace and then do like an AJAX call to your publicly available server and send the data to that server, so that you have a log of every time a user was using your application in production. You can see what was going on because they may be doing something that you didn't test. because users are very good at doing something like that. So you can get that log so that you have it. You can also include, besides what's in the console.trace, because it's on the window, you can find out, you can send in information about what device the user was on, what version of the operating system they were running on, what browser they were running on, what version of the browser. So you can get an idea of the user's environment that they were using so that you can use that for doing it with the console.onError. This is a great way to handle things. And the last thing that you should put in this is something that will, by default, like go to your home page so that the user's just not sitting there with an error message and they're stuck. So you can basically recover from that. If you don't want to do the onError, you can always add an event listener in your application to do the exact same functionality. And when you do the onError, you tell it that you're listening to error, which means something happened that was not caught, and you give it a callback function. Same functionality as what you would have put in the onError that you would put into the event listener, where you put the console.trace, send all of that data back to your server, and then somebody can go through the logs. And if you start to see a pattern, let's say all the users, they go, they're on your home page and they go to a product and they pick a particular product, and when they go to a certain product, it crashes. Well, you start to see that in the logs, and then you can go in and start looking at your code and see why is it that all of these people that are having problems are always going to this exact same point, and you can figure it out and resolve it, within your application itself. So that's the main thing that I wanted to do, was to show you when you have an error message in your code, you have a lot of options available to you. A lot of options besides just doing a console log. There are a lot of console methods that you can use. You can use a console.table. You can use debug if you want to debug your code while it's in production, because you're not able to put code in while you're working on it. And then also, then you can be able to capture things when you actually roll your code out into production. So this brings us back to the moment that I know you all have been waiting for. So we have our 3 truths and 1 lie. So I'm going to ask for a raise of hands. How many of you think, number 1, I have climbed the highest mountain on 4 of the 7 continents is not true? Okay. Number 2, how many of you think I did not graduate university with the 4.0 GPA? Okay. Number 3, how many of you think I did not ask Prince Charles for his autograph at a Georgia football game? That's true. That is true. He didn't give it to me, bastard. Number 4, how many of you think I do not own more toy soldiers than Sir Winston Churchill? And that is true, I do. I'm very proud of my toy soldier collection. But number 2, for those of you who think I didn't graduate university with the 4.0, she's pleased with herself. I wish my parents were as pleased as you were, but they're not. I did not. I actually only made 1A in all of college. So, I mean, I got 1 in, so it's like, well, why try to beat it, But thank you very much for coming in. I think we've got a few minutes left if you have any questions. So, all right, any questions? Nope. Thank you very much for attending. I appreciate it. Hopefully I will see you all next year at the 2nd anniversary of the Refactored Tech Conference.